You've spent this whole AC series learning the pieces: reactance, impedance, power factor. Today we put every one of them to work on a single messy combination circuit. We'll reduce it step by step down to one simple load, and every number we circle along the way is an answer you'd write on the test. Here's the circuit: 120 volts, 60 hertz. On the right, a heater and a motor coil sitting in parallel. That's our load group. And it's fed through a line that has its own resistance, its own inductance, and a capacitor in series. So we've got series and parallel, mixing resistance, inductance, and capacitance all at once. Let's tame it. Rule number one: in AC, every part is an impedance. A resistor just stays R. An inductor becomes plus JXL, a capacitor becomes minus JXC. That little J means the reactance sits 90 degrees away from the resistance. And notice, XL and XC point in opposite directions. Hold on to that, they're going to fight. We start exactly where DC taught us. Collapse the parallel block first. It's 10 ohms of resistance in parallel with 10 ohms of inductive reactance. Same product over sum as DC, but with vectors. 10 at 0 times 10 at 90 divided by 10 plus J10. That comes out to 7.07 ohms at 45 degrees, or 5 plus J5. So answer 1. The group behaves like a 5 ohm resistor in series with 5 ohms of inductive reactance. Now redraw it. With that block collapsed, the whole circuit is one big series loop. Add up all the resistances. 5 from the group plus 3 from the line. Resistance total is 8 ohms. Circle it. Now the reactances. The inductive ones add 5 from the group plus 4 from the line. XL total is 9 ohms. The capacitive reactance total is 3 ohms. And here's where they fight. Net reactance is 9 minus 3, 6 ohms. And it's inductive because the inductor won. Now the whole circuit is just one resistance and one net reactance. Combine them on the impedance triangle. Z equals the square root of R squared plus X squared, square root of 8 squared plus 6 squared, square root of 100. Impedance total is 10 ohms. And the angle theta is the inverse tangent of 6 over 8, 36.9 degrees. So Z is 10 ohms at 36.9. Circle it. Ohm's law never left. Total current is voltage over impedance, 120 divided by 10, 12 amps. And because the circuit is net inductive, that current lags the voltage by 36.9 degrees. Power factor is just the cosine of that angle, which is also R over Z, 8 over 10, 0.8, lagging. 0.8 means only 80% of every volt amp does real work. The rest just sloshes back and forth. Now the three powers. True power P is I squared times R. 144 times 8, 1152 watts. That's the real work being done. Reactive power Q is I squared times X, 144 times 6, 864 VAR. That power does no work. It just cycles in and out of the coil. Apparent power S is volts times amps, 1440 volt amps. That's what the wire and the utility actually have to carry. And check it. Power factor is P over S, 1152 over 1440, 0.8. Every path gives the same answer. So there's the entire exam on one board. Resistance 8, XL 9, XC 3, impedance 10, current 12, power factor 0.8. And the three powers, 1152, 864, 1440. One method got us all of it. Turn every part into an impedance. Collapse the parallel groups, then read the two triangles. Next time, we head back to the board for a real-world problem you've searched for. Grab a pencil, and I'll see you there.